welcome to Math World. Today we're going to talk about triangle relationships. And basically this is just some rules about triangles that we should know and how we can use them to solve some algebraic problems. Alright, so the first thing we should know about a triangle, well, we know that all triangles have three sides, right? But that also means that all triangles have three angles, okay? There are going to be three angles that make up this triangle, and we can call this angle A, angle B, and angle C. And that's a fact. All triangles have three angles. But what's more important is that we have to understand that all three angles of the triangle will total 180 degrees. All three angles total 180 degrees. Okay? And there's a few reasons why that works. The main one is, kind of that if you think about a line is 180 degrees, right? From one side to another. If you were to think about the arc, this is a complete 180. Remember back to our kind of our rotation, our rotations, that was a 180 degree rotation. And so if we take angle A, B, and C and we total them up together, maybe we say angle A is 40 degrees. Well, that would kind of like be from here to here. This is about, sorry, it's a little bold, but let's say that's about a 40 degree angle, 40 degrees. And maybe angle B is 60 degrees, so that's going to be a little bit further, maybe all the way to this far. And you kind of like, this looks like half of a pizza pie, right? So there's a 60 degree angle. And so then angle C must be what's left over to get it to 180, to get it to go all the way around. 40 and 60 is 100, so this must be an 80 degree angle. And that's kind of the remaining piece of the arc here. And that would be an 80 degree angle. And so all three of those angles added up will total 180. They kind of bring you back to where you began. You started at angle A, then angle B, and angle C, and then you end up back at angle A. So it's a full 180. And that's a fact of triangles. All triangles, the three angles must total 180, period. All right, now, how does that help us be able to solve some problems? Well, if I gave you kind of a mystery triangle here, and it doesn't really matter what the triangle looks like, it should always total up to 180. So let's say I give you some mystery sides. I say, okay, this is a 30 degree angle, and this is an 80 degree angle. All right, can we use what we know about triangles to figure out what is that missing angle? I don't know. Well, we're going to kind of set up a little problem here. We say, okay, well, if I know two of the angles, if I know one of them's 30 and the other one's 80, well, what is the missing angle needed that I can add to the first two and total 180 degrees? And I'll let you give you a second to think about it. But hopefully you're thinking, okay, well, what is that mystery number? Maybe we can group the two we know. 30 and 80 make 110. And I'm going to switch this question mark to an X just to kind of make it look a little more algebraic. And how can I get to 180 from 110? Well, if I subtract 110 from 180, I will figure out that my missing number must have been 70. Is that what you said? Did you say 70? And so hopefully you said this missing angle was a 70 degree angle, because that's the only only measurement that would add up to 180. All right, so there's our first concept, is that all three angles must total 180. All right, so our next concept that we're going to build on this is, it's called an exterior angle. And so let's try to rebuild that very first triangle and see if we can use it to show us one more relationship. And this time I'm going to create the triangle, but I'm also going to kind of extend that bottom line, and that's going to be called an exterior angle, okay? And so let's see how this works. All right, so we're going to be using our very first example. Let's drop in our 40 degree angle. Our angle B was 60 degrees, and the last one was 80 degrees, right? All right, those three total up to make 180. Great. All right, now this little angle here, though, and maybe I'll change my color. Let's see. This angle on the outside of the triangle, that's going to be called an exterior angle. Okay, an exterior means like on the outside, right? An exterior angle. And some things we should be able to figure out about this exterior angle. Can we figure out what its value is? And we should be able to do that based on the same reason we were able to say that all lines total 180. Well, there's like a little line here that should also total 180. These would be considered supplementary angles. If you remember what that meant, is that two angles that form a line, like 80 degree and our mystery angle, they should total 180. So what does that exterior angle have to be? Let's see if I can erase the question mark. 80 plus what makes 100? 80 plus 100. Oops. 80 plus what makes 180? 80 plus 100 would make that 180 degree angle. So you see the 80 degree angle inside the triangle plus the exterior angle, that will also total 180. Okay, so there's our exterior angle. We can figure that out using our supplementary angle math. All right, now what's a little bit more interesting about this is that the exterior angle will also equal the sum of the two remote interior angles. What is a remote interior angle? That's going to be the other two angles that are inside the triangle. So we're going to say that this angle here and this angle here, 60 and 40, these can both be considered, they're going to call it remote because it's like, remote means like far away, kind of like when you use a remote to change your channel on your TV when you're far away. So it's far away, it's a remote. And they're interior angles because, well, they are inside of the triangle. Remote interior angles. All right, so do you notice any relationships between the two remote interior angles and how they relate to our exterior angle? Well, our exterior angle we just said was 100, right? We figured that out, that it was 100 degrees. Well, our exterior angle we said was 100 degrees. We figured that out. And if you look at the two remote interior angles, hopefully you realize that they, 60 and 40, total 100 degrees. The 40 plus the 60, that totals 100, meaning that the exterior angle will always add up to the sum, that means add, of the remote interior angles. Interior angles. All right, so that means that the two remote interior angles will always add up to equal the exterior angle. All right, that's kind of interesting. Let's see if that applies to maybe our previous our second example, our red triangle. Let's see if I can extend it. So what if I said, what if I took this line and I extended it further here? And I said, oh, what would this angle be? Could you figure out what this missing little purple angle is over here? Well, this is an exterior angle, right? And this should add up to the sum of the two remote interior angles, which in this case is 30 and 80. So this should add up to the 30 plus the 80, or 110 degrees. And that is true. This would be 110 degrees. Which of course, 110 plus the 70 plus this 70 here, these also add up to 180. So you kind of get that 180 relationship a whole bunch of times. All right, those are the two relationships that we're really going to focus on, is that all three angles inside the triangle must add up to 180, and the two remote interior angles must add up to the exterior angle. Any exterior angle must equal the two far away interior angles added together. Okay? All right, so that is our triangle relationship math for today, and I will see you in class. Hey class, it's Mr. Bigsby with a hat, and I've got a challenge problem for you. All right, here is a triangle with an exterior angle, and I'm going to give you a little bit of information, see if you can figure out the rest. All right, what if this angle was 40 degrees and this angle was 80 degrees? All right, can you figure out the missing angle up here, we'll call that X, and this missing angle, Y? All right, leave the answer for X and Y in the comments later. Now for a word from our sponsor, Paper Cut Games. This week's game, Robo Rally. All right, Robo Rally is a really old game, but one of my absolute favorite games. It's a little bit of a programming game, but it has a really cool, like everybody runs into each other atmosphere. All right, so the way this game works is that each person, you start off by picking out a robot. So you pick out a robot in a character sheet, like a spin bot or a smash bot, and you get a character sheet. Then each person starts on the maps. And one thing that's really cool about the maps is that there's lots of maps and you can interchange them or even add them depending on how you want the game to go. So you put your robot on the map, and then during your turn, you're given these little programming cards that can only do certain things like move one space, rotate left, maybe move 3 spaces or move backwards. But you play these out and you put them face down, and you can only put out like, I don't know, 5 of them at a time. And then when everybody's ready, you're going to flip them over and tell your robot what to do. But the thing is, once you program your robot, you can't take it back. So that's when the kind of the hilarity ensues, is that these robots, one person will be like, okay, move forward 2 spaces, and the other one might turn right and then actually bump into them and move them out of the path of where they thought they were going to be going. And of course, the game board has traps that you can fall into. Sometimes there's these conveyor belts that send you where you don't want to go if you don't think about it properly. And the robots do shoot each other at the end of each turn. There's power-ups in the game. You can get stuff like extra memory or a double-barreled laser. And the goal of the game is to make it to a checkpoint. You put out these different checkpoints on the different maps, and if you can collect the checkpoints without running off the map or getting shot up by other robots, then you win the game. And so it's a really cool game, just because of how fun it is. The more players, the more chaotic it gets, trying to get your little robot across the map safely. Well, that's Robo Rally. I highly recommend it. This is Mr. Bigsby, and I approve this message.